Hello, am I audible now? I hope I will be audible. Yes. Okay. I think there was some issue. I was trying frequently to speak on one, but okay. Let's keep it aside and welcome back everyone for the FOSS Files, and this is our episode 3. And in the recent and as we all know, our the theme of this season is cryptography. So, in the past two episodes, you have learned much much various things about some basic concepts about all those cryptography things, which are actually prerequisites for our upcoming episodes. And our today's episode is the crypto bridge. And who doesn't know about the cryptocurrency, right? And that is, I think, one of the trending topics in the world. Cryptocurrencies. It may be Bitcoin, Dogecoin. There are multiple types of currencies which are there in the world, and we all are familiar with some of them. Or and we all know that, such things like cryptocurrency and all will be having more demand in the future. So yeah, anyone invested in that was my question as well. Anyone invested in the crypto? I think so. No. Okay. Anyone holding bitcoins? Yeah, but like, just tell me, uh, which are the cryptocurrency that you have heard about? The one example, Bitcoin. Yeah, Dogecoin is also there. Any other currency? Yes, Ethereum is there. Solana. Yeah. Those brave users also know. The brave users, I think, know more about that. I think brave users must know about BAT. What is BAT? Yeah, TRX. Yep. So yeah, there are multiple types of cryptocurrencies available in today's market, and in the upcoming pacing world, we will be, I think, experiencing more than these as well.
Okay,
So
I think it's time
okay,
we
yeah.
should start. Thank you, Soumitra.
Yes, thank you. And just before starting, just one thing that I want everyone to be part of. Just type ready if you are there in the chat, so that the presenters will also get some little motivation to present upon. If you are there, just type ready or let's go. You can type anything, so that our presenters will get some motivation, right? Yes, let's go. Ready? Yeah. So
Let's go.
I think it's time to start. Over to you, Aditya.
Yes, yes. Thank you, Soumitra. So, uh, today in today's episode, that is episode number 3, but we are going to look at our protocols, all protocols. Like in the last 2 episodes, we saw the actual algorithms, cryptographic algorithms, right, for hashing and symmetric as well as asymmetric encryption. That discussion was more theoretical, and but what we aim to do today is look at uh, actual real world applications, how these algorithms are applied in real world protocols to make things secure and everything. So, as we discussed right now, cryptocurrency is one of the most uh, fascinating applications of this field, cryptocurrency and blockchain in general. All that is what we are going to look into today, as well as PGP and GPG. So these are technologies which combine all of this. As you'll see, all the three topics, hashing, symmetric, and asymmetric encryption that we covered previously, all three are used everywhere in today's protocols, as well as SSL/TLS, which is used for securing your web communication and everything. Okay, so with that, let us start and request Sharvari to take over.
Yes, Aditya. So let's move and see what is the agenda for today's episode. Yes, so as you can see, the table of content, that is the blockchain overview. Here we are going to take the overview of the blockchain, like what exactly blockchain is and what are its applications. Then we are going to see what is PGP and what is GPG, and we are also going to dive into the hands-on of GPG. Next up, we have public key infrastructure, how the public key infrastructure is and what are the CA, RA, and everything. And also, as we all are familiar with the SSL certificate, right? So we are going to see what exactly SSL is and its application. So moving further, as we have seen what are the applications, like as Somitra mentioned, different types of cryptocurrencies, right? So blockchain technology is a type of distributed ledger technology. So, can anyone tell what exactly ledger is? As you can unmute yourself or type in the chat box. Yes, speed up, guys. What is ledger?
So, has anyone had this experience where they go to a shopkeeper and they get some goods but they do not pay immediately? Instead, the shopkeeper writes down the co- mon- the money owed into their notebooks and everything, and then we settle at the end of the month. Exactly, a record. So, ledger is
Yes,
exactly that, a record of all the transactions that have taken.
Yes, exactly, Aditya. It is a record of transaction. Now, again, I'll simplify it. Suppose Ashutosh has borrowed 100 rupees from Pooja, right? So, what Pooja will do is she will quickly note it down somewhere, and she will, like, to remember it. And that note is nothing but what we call ledger in simple words. Now, what if I say Pooja does not keep that note to herself only? Instead, what she will do is she will share this to the group and tell that she Ashutosh has taken 100 rupees from her. Then what Ashutosh will not be able to deny that he has taken 100 rupees, right? Or he will not able to tamper or erase that note, right? So this is what blockchain exactly is. That is, it cannot be tampered, it is immutable. Again, it is totally transparent and distributed. Like, as I told, she can share it to the groups. Similarly, this blockchain is also shared to the network, and each like node or the network, the node from the network has that copy of the blockchain. So, blockchain is basically the ledger which is distributed among the network. So, let's see what exactly it has. Here, as you are able to see, each block in the blockchain. So, basically, blockchain, as the name suggests, it is a chain of a block, and each single block represents a single record. Now, what this record consists? It has the relevant information. That is, if we take the example of cryptocurrencies, then the relevant information would be the information about the transaction. Then we have cryptographic hash and the hash of the previous block. Now, can anyone tell, like, if we connect the dots to the previous episode, that was episode number 1, can anyone tell what cryptographic hash means, or what basically hash is? So yes, we have people typing over here. Yes, it's a mathematical function to compress down the data. Exactly. It's functions like SHA. Yes, SHA is the example of hashing, right? So what we do here is it's not compression exactly. It just like it's hashed that cannot be the human readable, right? So the information is just converted into the ciphertext. So we'll see what happens over here in the blockchain. So there is a block, and each block, the information in that block or the record is first converted into the hash, and that block also stores the hash of the previous block too. Like, if we take the block number 2, then what it has is, it has the hash of that record, and also the hash of the previous record too. Now, the block that does not store any of the hash with the previous record is known as the genesis block. It's just similar as the linked list representation, right? So, what will happen? What do you think? What will happen if someone attacks on this block number 2? Then, will he able to change it? Okay, let's see what happens if someone tampers the data in the block number 2. Then its corresponding hash will also change. Also, if we take the case of third block, it stores the hash of the previous block, right? So it's the hash of that previous block is already changed, so that information or the record in that block 2 will change, right? So this will continue throughout the chain, and if one block is changed, then that all blocks in that chain will also change, right? So if someone tries to attack on one block, then all the corresponding blocks will also change, right? So this will ensure the immutability and the transparency over here. Like if we take the case of bitcoin, then for adding each new record of the bitcoin, the time required is 10 minutes. So let's say if the attacker attacks on one block, then he has to like in such a small time he have to change it. Like all the miners are there to change that block or to add new block. Between that time the attacker has to change it, and it's not feasible, right? Like in bitcoin, the time required is 10 minutes. So if we take there are 10 million blocks, then the time will go up to 200 years, which is not feasible. So in this way it is nearly impossible, right?
Okay, so
Yeah.
so I'll tell you why this is very hard, because the hash that you have to calculate, although they use algorithms like SHA-256, we saw that it is very efficient and everything, but we can't just directly calculate the hash. We need to have a very special hash we need to calculate, which is according to the proof of work algorithm, which you'll see next. But that is the idea, that it is very hard in the sense, for example, in proof of work, we need to have massive amount of computational power in order to calculate that particular hash value. Not just any hash value will work. So each of these blocks here, they store a transaction, multiple transaction records. Like they might contain thousands of transactions. And at the end, we have the hash of that entire block. At the top is the hash of the previous block, and the bottom is the hash of the current block. So this calculating this hash is very difficult, because again, we'll see in proof of work. Okay, just a little
Yes, exactly.
clarification.
Yeah.
And what miners do is, what the term you hear, mining. So mining is basically in the process of finding this a special hash that will work in the blockchain. So this, because it is very hard and very computationally intensive, miners require a lot of computational power, and that is what makes it secure.
Yes,
Okay.
exactly, Aditya. Like there are the jobs for mining too. Like crypto miners are there. So what they like they are awarded the Bitcoin if they solve that puzzle. So if anyone is interested into that, they can look for it. Right. So let's see how. Yeah. What is the consensus mechanism here? That is, as Aditya told, there is a proof of work. The proof of work is something like it's the basic requirement in this blockchain. Like what happens is the time mechanism, like if for the particularly for bitcoin, the time required to create a new bitcoin is 10 minutes, right? So that you have to prove, that is nothing but proof of work. Now what happens here is the blockchain you have created, there are copies of that particular blockchain or that records with everyone who are present in that network. It's similar like we are sharing the google doc, right? So you might have copies with everyone. Yes. So this like these two here too, similarly that blockchain, there is a copy of that particular blockchain with everyone. So if you want to make change in that record, what you have to do is you have to first calculate the hash or change it, and you have to prove that this much time is required to change that particular record. And also you have to share your change record to everyone in that network. So now these people in that network, they will what they will do is they will first check whether the change is valid or not, or whether the change anything is tampered with it or not, and they will vote. If it is valid, then they will vote for yes, or if someone is not agreed with it, then they will give the negative votes too. So to change you have to own the 50% of the network, right? So you can imagine for an attacker to attack this, to change the hash values of everything, and also they have to own the 50% of the network. This is not feasible. That's why it is the blockchain is the most secure one. It is immutable and it is transparent.
Okay,
So what
so
do you think?
I have
Yeah.
one couple more things. So on the blockchain, every user, so in normal website on normal websites, what you do is you sign in with your email and password and everything. On the blockchain and Web3 in general, what your identity is not tied to any of these things like username or email. It is just your public key. So each user has their own public private key pair on the network, blockchain network. And what they do is, if suppose I wanted to send money to Sharvari, so I have my public and private key pair, she has her public and private key pair. So what I'll do is I'll create a transaction with like sending one Bitcoin to Sharvari. I'll sign that with my private key, and that can be verified by everyone that this transaction is what I agree to. And then I'll try to put it into the blockchain by broadcasting it to everyone. So what miners will do is they'll hear my transaction, they'll record it in their block, and then they'll try to calculate hash for it. And this hashing process is very difficult. Why? Because the hash, as I said, it needs to be a particular type. What is that type? So I'll tell you now. It has to be less than a certain value. That value is determined by the algorithm. So hash, we know, is a 256-bit number, you can say. Short of 56 is 256-bit number. So uh, just imagine that because it's totally pseudo random, we have to just brute force it, and it by means of probability only. They calculate the total number of miners. So suppose there are 10 million miners, each can calculate a billion hashes and everything. So they do the math and make it so that even if all that brute force power is used at once, uh, the probability is so low that only one hash can be calculated every 10 minutes. That is how low the probability is with the entire brute force power of the entire network. So once that value is calculated, then everyone just trusts that value because obviously a lot of work has been done to calculate that value by whoever has calculated it. So whenever, and this is usually uh, for sustained calculations. Like if I wanted to, let's say I wanted to forge something, I wanted to forge transactions, then I would have to calculate this value for every single block after I forge that transaction, and not every uh, for everyone to be able to believe that blockchain, which is impossible basically. That is how it works.
Yes, Aditya. Now we'll further see what is the use of public and private keys in blockchain. Yes, as Aditya said, like to make the transaction, we have to take a public key and a private key, right? So here in blockchain, we'll take an example of cryptocurrency. So if you are going into cryptocurrencies, then you are likely to have the crypto wallet, which contains, like, it is similar to your wallet only, but instead of containing the bitcoins, it contains public key and a private key. So what this public key is used, it is used to create the wallet address. Like it's similar to the address in, like in Google Pay, you might be having any address like the okay, bank access something is there, no, like that, or your phone number. Similar to that, here too there is one wallet address, and that is shared publicly, whoever you want to from whoever you want to receive the money. So let us again take an example, like Yash want to send bitcoins to Aditya. So, what is the guarantee that he is sending that particular, he's making transaction with Aditya only? So, this is verified with the help of public and private keys. Like what public key will do is, public key would be able to verify that this is say that I am the sender, and it is sent to the right receiver. And also the private key is used to check that I own this transaction or these bitcoins and I can transfer it, right? So this transaction is done. Like now, suppose Aditya will receive it, and there is the there is the signing with the help of the private key, right? So this can be verified that it is came from Yash only. Okay, so let's move forward. Now we will see what are the applications of blockchain. Like the first and foremost, we all know that is the cryptocurrency. As Soumitra also told, what are the examples of cryptocurrency, like Bitcoin, Dogecoin, and also many more examples are there, like Ethereum and all. So here's one interesting fact: like the first transaction made over the Bitcoin with the help of the Bitcoin was the purchasing of two pizzas. Interesting, right? So next up we have voting systems. Like what do you think the blockchain, like voting systems will make use of blockchains? How blockchain will be made use in the voting system? Okay, so let's see, if someone votes to a particular candidate, right? Then that vote is recorded and it is shared to everyone so that there would be transparency, right? So this is shared, and that votes are not able to tampered. Like it is shared with everyone, so there will be, it will get spot which transaction has been changed over there or what record is changed. So in this way the voting system would be more and more transparent with the help of the blockchain. Next up, we have smart contracts. Now, what this smart contracts is, it's similar. Like suppose you are buying or selling the land, or you are lending some money. Then there are contracts, right? So this is nothing but a more secure and a digital contract, that is smart contract, which makes use of blockchain. Next up we have DeFi, that is decentralized finance. You might have heard the scam 1992, right? So can anyone tell what was the scam? Okay, so as we know, like that scam was that particular man, Harshal Mehta, what he did was he gave the fake bank receipts to the bank, and he was acting as a broker, right, or the middleman. So he gave the fake bank receipts to the banks, and he just said that this is the bank transfer from another bank. Like he just gave it fakely. So this would have been protected with the help of blockchain, as there would be uh, transparency and there would be no middleman over here in blockchain. So in this way we can use blockchain in decentralized finance. Next up we have supply chain management. Like, have you ever wondered how the Amazon would be taking the goods from the like providers? Like, if we take the case of Amazon and Apple, like Amazon want to sell 1,000 mobiles online, and they will take it from Apple, right? So the 1,000 iPhones are shipped from the Apple office to Amazon. So there might be a case like in the middle of the shipping, the suppliers would make the shadow swapping, right? So this can be avoided as block as Apple also stores the blockchain, that is it stores all the records, and also Amazon keeps the track of all the records, so there no shadow swapping would be done. In this case we can use blockchain. Next up we have healthcare records. Like you might have seen the records of a patient are stored for so many long time in that hospital. It is with the help of the blockchain. Okay, so let's move forward. So next up we have pretty good privacy, that is PGP. So what PGP is, it's an encryption technology. With the help of the PGP, we can encrypt files, emails, and even the file systems too. There are many more uses of PGP, and it is basically used for encryption. Now we'll see what it makes use of. It has a symmetric encryption, that is, it encrypts your data fast. Then it has a symmetric encryption, that is, exchanges the keys securely, and it also has the digital signature. Now over here, can you tell why it might be using symmetric encryption too and asymmetric both at the same time?
As we discussed about this in the last episode, in the end, why would we use both asymmetric as well as symmetric?
Yes, it would be a quick recall, right?
Indication and verification. So that was for
Yes.
the two types in asymmetric. For using both symmetric and asymmetric is that symmetric is fast and efficient, whereas asymmetric is more secure uh, from middle, man in the middle attacks and such. So we use a
Yes,
combination of both.
exactly. To make it faster and also to authenticate. So the techniques used in PGP are, like we have seen, it uses asymmetric and symmetric both encryption, right? So it is nothing but the hybrid cryptography. Next up we have digital signatures. Can anyone mention what are the digital signature algorithms? Like I have almost told it.
Anyone remembers the three algorithms that we discussed? RSA, exactly, RSA, DSA, and one more
Yes.
was elliptic curve DSA, ECDSA.
Yes. Then again we have hash functions, and that is the SHA-1 algorithm or SH256 too. Then we have web of trust. Like we are again going to see it further what exactly web of trust means. For now, just remember that there is no intermediary between the two sender and the receiver. That is nothing but the web of trust. Then there is a data compression in PGP. Now let's quickly see what is the functioning, like how does the PGP exactly works. Yes. So let us consider we have an information, like let's say it's email, and a person want to send email. Then what happens first is it is first hashed with the help of the SHA-256 algorithm. Then it is digitally signed with any of the algorithm like DSA or RSA with the help of the sender's private key. Then this original email and this digitally signed information both are zipped with the zip algorithm, and it is compressed. Now this compressed output is again encrypted with the help of the session key. Now this session key can be any random key which is symmetric. Like the symmetric encryption algorithms are used over here to encrypt this, that is AES standard algorithm, right? Or we can also make use of ID algorithm too. So this S key is again encrypted. Like normally what happens, we just encrypt the message, right? But here the catch is we are also going to encrypt this uh, session key 2 with the help of the RSA, that is a symmetric algorithm. Now this message, the compressed output which is encrypted, and this session key, this both encrypted keys are concatenated together, and they are like sent to the receiver. Yes, symmetric key itself encrypted with the help of the asymmetric key, right? So these all the encrypted keys are then sent to the receiver. So what do you think if someone loses the session key? What will happen?
They'll lose the encrypted data.
Yes, exactly. We are going to see it further. What happens there too? Okay, so let's move further and let's see what is GPG, that is GNU Privacy Guard. So GPG is the like open source version of the PGP. Both PGP and GPG works on open standard only, but PGP is now not widely used. Instead, as GPG is open source, it is widely used. Like you can see, it is used in Git commits and tag signing. You might have noticed that there are functions used over there in git commits too, right? So in that way it is used. Next up we have package manager security. Like you might have installed the pacman or apt package managers, right? So in that the gpg is widely used to ensure that the package is not tampered with, or it has the integrity, right? So for that gpg is used. Next up we have encrypted messages, like as we have seen in the PGP. Similarly, the messages or the emails are encrypted with the help of the GPG. Then we have a verification of software downloads. Like if we are going to download something over the internet, then it like softwares or the internet, then it first checks that the software is not tampered with, and it will also prompt you that it's not like safe and something. So this is made with the help of the GPG. Then we have Docker image signing. If we create the image, then while fetching that image, it says that like the GPG is used over there, and it will also see that it is integrated and it is like not tampered. Then we have signing of PDFs or documents. So you people might have seen the green tick over the documents like Aadhaar cards, right? So this is uh, yeah. So this is nothing but similar to the GPG signing. Okay, so for that we'll just dive quickly into the hands-on how exactly GPG works. Let me share the screen. Yes. So is the screen visible? So let's first quickly create a key with the command gpg hyphen hyphen full hyphen gen key. Yes, so it will prompt what type of key you want to create. It will ask for certain of algorithms. We'll go with the RSA. Basically, the key pair is created over here. We'll go with the RSA. It will ask like what key size do you want. So it's always better to have the larger key size. So as RSA ranges between 1024 to 4096, so we'll go with the 4096. Yes, next up it will ask for how much time the key should be valid. So we'll go with the 2 days. As you are able to see, it's saying that the key will expire on 29th of December. Yes, it's correct. So we'll go with the name. So basically, it's the email of the recipient. Right. So everything is set up over here, and here we go. It will prompt for the passphrase. Okay. Yes, so as you are able to see over here, the key created is the type of RSA that is in size 4096, and it will expire on 29th of December. And this is nothing but the key we have got, we have generated over here. Now we'll make use of this key. Yes, for that, first of all, we'll create a file. Let's say echo, and we have the message that is hola amigos. Yes. So you are able to see here there is one just file. Now we will first sign this file with the command that is gpg armor detach sign and the file name. So what this armor means is the flag armor says that you have to create a file in like it can be the binary file or the ASCII values. So what do you think? What would be better, ASCII file or binary files? So here we are going to create the ASCII values file, and the detach. It means that yes, exactly, it's ASCII. Detach means that a separate file is created without tampering that original file. So let's see what happens over here. It will again ask for the passphrase. Yes. So you are able to see here the file.asc is created. Now let's quickly check what is there in that file.asc. Yes. So as you are able to see here, there is a hash value and the signed value too, which is not in like it's in ASCII value, but it's not readable, right? Now we will verify that if the original file and the file we have created is same or not. With the command gpg verify and the file.ascii file with the file original file we have taken here. Yes, so it's saying good signature from the recipient and all everything is good over here. Now, what we will do is we will encrypt that file with the command gpg-r, that is recipient. The flag is used for recipient and the recipient's email. org. Again, we'll give the flag -e, that is to encrypt, and the file original file is encrypted over here. If we'll see, the file.gpg, that is the encrypted file, is created. Now again, we'll see what's exactly there in that file.gpg. Yes, as you are able to see, this is the total encrypted version of that original file. Now, what you can do is you can share this file that ASC or the file.gpg over the network, and you don't have to worry about your data because it can only be decrypted on the receiver side by the receiver's private key. So. Sending this file over the network is totally safe. Now we'll try to decrypt the file, that is the encrypted one, file.gpg, with the help of the gpg-d and the file.gpg. Okay. So here the message we have given is hello amigos. So in this way, this file is decrypted with the help of the GPG. So guys, that's all about GPG, and as we have seen the hands-on, this is exactly the working of the GPG. Yes, now we'll further move to PKIs. Over to you, Sandesh.
Thank you, Sharvari. Now let's move on to the new topic, which is the public key infrastructure here. So before moving to the PK, actually, let's have some recap and have some questions here. In last episode, we have seen that the symmetric encryption as well as the asymmetric encryption, right? Symmetric encryption, we have using the same key for the encryption as well as for the decryption, right? And in asymmetric encryption, we have used the two different keys. One is a public key and one is a private key, right? So, am I audible actually?
Yes, you are.
Okay,
So
okay. So,
one thing, just 1 second.
okay,
So I'll summarize what GPG was. So GPG is where everyone has their public-private key pair, and they want to send any data between. Hello. Okay. So GPG, I'll very briefly summarize what it was. GPG was basically where you had to send encrypted data to one another. So what you do is everyone has their public-private key pair, and they encrypt the data with symmetric encryption, but encrypt the key with asymmetric encryption so that it is safe from middleman attacks, man in the middle attacks. Okay. And then they basically transfer the data, and it can be verified and decrypted by the receiver easily, and that verifies that it has not been tampered with. But all of this basically lies on one fundamental assumption, is that is the receiver already has the public key of the sender. Okay, just remember that. Okay, is this clear? And then obviously the implementation GPG makes a lot of sense. It abstracts away a lot of that stuff. It provides a clean interface. We can do all of these things. Okay, back to you, Sandesh.
okay. We have seen in last episode, we have seen that the asymmetric encryption, right? We have seen that there are two keys, public and private keys, right? So most of the persons think that the public key is actually used for the encryption purpose only, and the private key is used for the decryption purpose. So I have one question that can I use a vice versa? Like, can I use a private key for the encryption and the public key for the decryption? What you say? Can it is possible?
So
Yes,
we saw this in digital signatures, right?
yes, yes, actually, because they are mathematically interrelated. So, before moving to the what is PKI here, let's have one a real life scenario here. That what was the problem there actually, and why there is a need of introducing the PKI here. So we will see that problem first, and then we will see the what actually a PKI. What is the actual PKI? Okay. Now let's see that there is two entities, one as a browser and one as a server, which is the client server model here. And they want to communicate here. And a browser has a session key, right? The session key is nothing but the symmetric key, right? For the encryption and decryption purpose. Okay. So a browser will create the session key for the data exchange here, and browser will send the data, which is encrypted with a session key, to the server here. But what server says that browser actually you send encrypted data to me, but I don't know what is the session key is here because the session key is present at your side, right? So what I will do right now, the server will send his public key over here to the browser and says that browser encrypt that session key with my public key here and send back to me. Okay, so browser will get the public key of the server here, encrypt that session key and send back to the server here. So remember that the server only server can able to decrypt that session key because the private key is only present at the server side here. Okay, so the private key is used for the decryption purpose here. So now the server will use his own private key here to decrypt that session key, and he will grab the session key here. Okay. So now the browser and the server, both of them have the session keys here. So now they can securely communicate over the unsecured network here. So they can transport the data and encrypt that data with the session key, and also decrypt it with the same key here. So what do you think? This is the safer way to communicate over the network, or there is any kind of loophole here? What you say? We are using a hybrid encryption here, right? Asymmetric plus symmetric here. Yes. Do you saw any flaw here? Any loophole? Any attempt of hacking here? Okay, let's continue. Suppose there is a man in middle here. Uh, uh, just remember that now I will not use a man in middle here. I will use a hacker ame here. Okay, so the WLJ has a one hacker in our group, which is the hacker ame here. Okay, so instead of using a man in the middle, I will use a hacker ame here. Okay, let's continue with that. Hacker ame, give the acknowledgement in the chat. Okay, now the same scenario here, like a browser, a client server model, and the browser creates a session key and encrypt that data and sends to the server here. And hacker says that yes, I'm watching you. Yeah. Now what actually hacker does here, that like server sends his public key to the browser, right? But hacker will grab that public key from the server here by intercepting the communication between the client, between the browser and server here, and he will replace his own key, a public key here, and send back to the browser here. So browser doesn't know actually the key belongs to the hacker actually, the hacker here. He think that it actually came from the server here, but it actually came from the hacker here. Now, browser will encrypt that session key and send back to the server here. So again, hacker will grab that session encrypted session key, and it will decrypt that session key with his own private key, right? Because he's sent his own public key to the browser, not the server's public key. So he has own private key. So he will decrypt that session key and grab that session key's access. So after that, what he will do, he will get the public key of the server here. Again, encrypt that session key with the server's public key, send back to the server. So browser and server think that it actually came from the browsers. Think that the public key of the server came from the server, and server think that the encrypted session key is actually came from the browser here, but it actually came from the hacker Amen here. So the three of the entities have the same session key here, right? So browser and server will send the sensitive data, any kind of data over the internet, and it can be read by the hacker Amen here because he has the access of the session key here. So that is the loophole here.
Okay, so as I understood the loophole, what Amir does is, on for the user, he pretends to be the browser and sets up a public private key connection there. And for the browser, he pretends to be the user. So that on both sides, he basically passes data while looking, also collecting it. Right?
Yes.
Hmm.
Okay. Now let's see the actual PKI here. So after that, we will see the same example, and we will see how the man in the middle attack will get eliminated with the PKI here. So the PKI is nothing but just the policy, you can say, or the framework like used to create, manage, distribute, use, store, and the revoke the digital certificates here. And it also ensures that these four aspects here, like confidentiality, integrity, authenticity, and the non-repudiation. So these four terms we already have seen in the first episode. I will not repeat here. So these four policies are actually maintained by the PKI here. So next we will see the actual components of the PKI. So these are the main components of the PKI here. The first one is an certificate authority. The second one is an registration authority. Third one as on digital certificates and the public private keys. We know the what are the public private keys and also the digital certificates, right? In a last episode, we have seen what are the digital certificates here.
Okay. So the fundamental problem here is that which public keys can we trust, as I see it, right? So in the previous thing, PGP is more of a decentralized system where public keys are shared with one another. So, for example, I want to share something with uh, Yash, for example, and but I don't know his public key, but I know the public key of uh, Sandesh. So and Sandesh knows the public key of Yash. So because I trust Sandesh and I have his public key, so Sandesh can send me Yash's public key and then I can send data to him. So that is how Yash and I can communicate based on mutual trust on Sandesh. And you can see can grow this network of trust can grow. So this is called a web of trust. This is the decentralized concept of trust. But as we find it, this is not really used so much in today's world because there are a lot of problems. It is very fragile. Even a single malicious person can ruin the entire thing and everything. So we used a more centralized approach in public key infrastructure that we are going to see right now. Use a central authority, a certificate authority. Okay.
Okay. Now let's see how actually a digital certificate is issued. We will see those terms actually. What is the CSR file? What is the RA? What is the CA here? Just like go through the procedure here. Suppose I am the developer of the WLG here, and I have purchased one domain here as an a wclog.org here, right? So what I want to do is like I want to like validate myself like I'm the real person, I'm the real owner of these domain. So I have to issue a digital certificate here, and also for the like safer communication, I have to issue a digital certificate. Okay. So what I will do, I will just prepare one CSR file. We will see that in the next slides also. Just like consider that it is the like combination of your personal information as well as the domain ownership information here. And we will send these CSR file to the RA. So RA is nothing but one like registration authority here. It like only validates that details of yours, like you are the actual owner of that domain, and he will send that request to the CA here. So now the actual CA will like issue a digital certificate here and send back to the RA, and RA will send back to the client here. So that's how the one digital certificate is issued. So now let's see one by one what is a CSR file, what is a registration authority, what is a certificate authority here. Okay, the first one is an the CSR, which is a certificate signing request here. So it just one a file which is like sent to the RA or the CA here, and it has its own standard, which is the X 0.509, which defines that the what are the fields which should be present in the CSR file, what are the data types it supports, and then it encoded in a PEM format, .pem format, which is just one base 64 encoded system, and the base 64 encoded system we have seen already in episode 2, right? So now let's see the content of or the fields of the CSR file. The first one is a common name, which is the domain name that you owns. Then the organization, like if you are the if you have the organization, then you can provide that one. Then the locality, which is the city, then the state, then the current country. This is related to the address information. Then the public key. So this is the most important thing here is the public key here. So before making the CSR file, you have to generate your own public private keys here, right? With any algorithm like asymmetric algorithm, RSA defilement or elliptic curve defilement here. So you have to keep the private key as an private or the secure on your system, and you have to give the public key to the CSR file. Then the signature algorithm, which defines that which algorithm you have used to create these pair of keys. Then the email address, just optional one. Then the subject alternative name, which is the SAN here. If you have the alternative domains for your the like for alternative domains from your the original domain, then you can provide it, or this is just a optional one. Then the version. So we have seen that the standard X.509. So these standard has different versions, and that version is mentioned here. So these are the common fields of the CSR file, just your personal information as well as the domain ownership information, along with the public key, which is the most important here. So did you get what is actually the CSR file here, or anyone has any doubt here? Okay. Okay, now let's continue with the registration authority here. Just remember that the array is just used to validate the CSR file here. So it will get your CSR file, and it will validates that you are the actual owner of that domain. Okay, he has the authority of that approving that incoming request or rejecting that incoming request, and it will verify upon different security checks here. So just remember that the array is used for just validation of your identity here. Okay, and it will send that request to the certificate authority. Okay, did you get what is array here actually? Just for the validation purpose, that array is used. Did you get it? What is array here? Okay. Then comes the certificate authority. So the certificate authority also can validates your identity here, and also issues a digital certificate here. So the arrays are introduced because to reduce the overhead of the certificate authority here. So if there is no array, then it actually doesn't uh, dis like the you can say that array is an optional one here. Okay, to reduce just the overhead of the certificate authority, the arrays are introduced here. So the arrays actually just validates the identity. It doesn't have the permission to issue the digital certificate here. But the the certificate authority has an authority to the issue a digital certificates here, and it will create the digital certificates upon the CSR file, and it will manage and all those things. Okay, so the roles of CA, that the issuing a digital certificate, establishing a trust. Okay, and the CA is actually the most trustworthy persons here, like entities here. Okay, you have to trust the certificate authority. In we will see in further examples, that just remember that CAs are the most trustworthy persons. They can't issue a fake certificates. Okay, then let's continue with the one scenario with the issuing a digital certificate here. Suppose for this example there is a no array here. Okay, now the client, what client will do, client will request a digital certificate to the uh, root CA here. Okay, actually root CA is the parent of all the CAs here. Okay, so what root say will do here, it will validates your details which are present in the CSR file, and based upon that he will issue a digital certificate here. But the problem was that like the actually CA, the signs that certificates with its own private key here, right? The We have seen that the private key actually used for the signature also, right? Okay, so the root say will signature make signature that digital certificate and send back to the client. But suppose the hacking up attempts is done, and the root says private key gets compromised. Then what? The certificates which are issued by the root say will gets compromised, right? Will gets invalid. Okay, so to tackle that problem, there is a chain of trust is introduced here. So there are one root root CA here, and there are multiple intermediate CAs here, and there can be multiple trees here, like tree-like structure here. Just not one layer of the intermediate CA. There can be multiple CAs under the intermediate CAs. So what root CA does that? Uh, it will issue a digital certificates for these intermediate CAs that says, like, root CA says that the intermediate CAs are actually those are also trustworthy persons or the entities, and they can also have authority to issue a digital certificate here. Okay, so we can keep the root say offline 99% time here, so that the private key of the root say will not get compromised here. So to save that the compromisation of the root say's private key, we use this chain of trust here. Okay. Did you get these ones, like chain of trust? What is a CA here?
Okay. I think I'll so we'll try to grasp the big picture here. So what we were trying to do is secure we wanted some mechanism to trust the private key that someone was giving, web server was giving. So we were visiting a website and we wanted to trust the public key of that web server. We wanted to make sure that there is no man in the middle. For that, what solution we found was there is an central authority CA that issues a certificate and that certificate, what is that certificate? It is just the public key of that server signed by the CA. And if it is signed by that CA, then we trust it automatically because we know the public key of the CA. So this basically has shifted the problem, right? So what happens is now we need a way to verify the public key of the CA. But the public key of CA is a special one where it is so global that it is just stored everywhere in your operating systems, in your browsers and everything. So uh, that is automatically taken care of. And any random public key, if your CA trusts it, then we can also trust it. That is the trust that we are building. Is that right?
Yes, exactly. Just
That
remember that the
mm, mhm.
yes, continue, Aditya.
And now to take the load of the root C. So there's something like the DNS system. You know that there are multiple layers to it. There are the uh, top level domain servers. There are the root servers and everything. Similar to that system, what happens is there is a root CA. And so why are we trusting the server? Because our CA trusts it, right? This is how the trust built. So what if we do? So all the websites, the millions of websites on the internet, if what happens if they are requesting to the root CA, it might get overloaded and everything, and it is not generally a good practice. So what they did was instead of a single central root CA, obvious what they'll do is they'll have some intermediate CAs one level below. So the intermediate CAs will have their own certificates which will be signed by the root CA, and they will sign the certificates for the web servers. And you can have multiple layers like this of CAs. And because we trust the root server, we can trust the intermediate server, and hence we can trust the web server. This is the chain of trust. So this grows like a tree. Um, uh, and the decentralized approach of GPG that works more like a graph, a general graph, where everyone connects to everyone. And the root CAs are very few. Like there are, I think, 100 or 150 some root CAs in the entire world, and all the keys for most of them are stored in your browser itself. When your browser is updated, those keys are also updated, so whenever it is needed, or your operating system.
Yes, exactly. Okay. Now let's continue with the next topic, like, which is the digital certificate here, right? You might have heard multiple times digital certificate, digital certificate. Right? Let's see what are the contents of the digital certificate here. The first one is a version. The digital certificate also has its own standard, like same as an CSR file has, like the standard X.509, and the version of that is mentioned here. Then the serial number. Just remember that the most important field is the serial number also. The serial number is nothing but just a unique field which is present in the digital certificate. Okay, so with the help of serial number, we can uniquely identify the all the digital certificate which are present in the world here. Okay, so serial number is the unique one here. Then the signature algorithm. The This is just a algorithm which is used by the CA to create their own public private keys here. Then the issuer. What do you think? What is the like? What information will be stored in issuer field? What does it mean by the issuer? Yes, the CA info, the info of the CA which issues this digital certificate. Then the validity period. Yes, which defines that how much time this certificate is valid. Then the subject, which is just a domain name, organization name. Yes, yes. Then the public key. What do you think? This is the public key of the server itself or the CA's public key? What do you say? Yes, server itself, right? In CSR file, we have seen that the server sends or the like gives his own public key for for the digital certificate signing request, right? Then the signature value. This field also important one here. We will see that in next slide what is actually a signature value. Did you get these ones? Like what are the fields which are present in the digital certificate? Those
So
are just simple
basically,
ones.
uh, just instead of just signing the public key and just basically just signing the public key, we include a bunch of metadata with it, like we mention a validity period and everything, and we create a format which is called a certificate, which includes the public key as well as all of this metadata.
Yes.
Mm.
And the next thing is the signature value. So now just stay focused here and just understand what is the signature value here because it needed in next further examples here. So just stay focused here. So we have the digital certificate, right? Like all the fields are present on the digital certificate that earlier we have seen that. So what CA does that? It will generate the hash of that data actually. Okay, it will generate that hash value with some hash function sh1 sh256 or the md5, and he will use his own private key to sign that hash value here. Okay, so it becomes a signature value. Okay, did you get that? Like it will get the hash value of the digital certificate, complete digital certificate, then it will encrypt with his private key, and it becomes a one signature value, and the CA will append the signature value to the digital certificate here, right? And he will send back to the actual the client, which is requested the digital certificate here. Okay.
So this is just the signing of it. Okay, so we are signing the certificate basically, and
Yes.
how we sign anything, we calculate its hash and then we sign the hash instead of the entire thing. That is how we sign anything, PDFs, anything. And this is how we are doing here also. We are, instead of signing the entire certificate, we're just creating its hash and signing that hash.
Yes.
We looked at this in the previous episode.
Now let's move on to the same example over here with the PK implementation here. So at top left corner, you can see there are three types of keys with different colors, distinguished in different colors. The first one is a public key which is in red, then the green which is the private key, and the session key which is in a white. Okay, there are three entities like the certificate authority, the browser, and the server. So the all of three of them have their own pair of public private keys here, right? And now you are thinking that browser has a CS public key here. Okay, so the earlier Aditya also mentioned that all the trusted CAs which are present in a world, so the public keys of those trusted CAs are actually present in our OS as well as also present in a browser itself. Okay, and if the public key of the CA gets changed, then it gets updated with the system updates, your operating system updates here. Okay, just remember that the CA's public keys are actually present in your OS itself. Okay, that's why the CA's public key is available to the browser here. Okay, so the same scenario, like browser sends encrypted data to the server, which is actually encrypted with the session key. The same thing happens that the server says that browser, actually I don't know the session key here, so I am not able to decrypt that data here. So what I will do, I will send my digital certificate here. In previous example, we have seen that he sends only the public key, right? But now he will send a digital certificate here. Now browser will get that digital certificate and first like sees that like expiration of that digital certificate or the validity of the digital certificate. If it not gets expired, then he will calculate the hash of that digital certificate again with the same algorithm. Okay, these considered as an current hash here. Okay, and after that he has a CS public key here, right? Now that signature value is encrypted with CS private key, right? So now he will use CS public key to decrypt that signature value here. After decryption, he will get that hash value, right? Which is actually calculated by CA. And he will again calculate this hash of that digital certificate again here. And he will compare that hash values. If there is a change in that hash values, then browser detects that it actually gets tempered here or altered. Okay. So in first episode, we have seen that if there is a bit of change in the original data, the entire hash will get changed, right? So the browser will detect that it actually gets tempered here. If the hash matches, then a browser says that okay, it actually not get tempered. So I will trust on the server here. There is no hacking attempt here. So now what browser does that? That it will extract that public key of the server from the digital certificate and encrypt that session key with that public key of the server, and he will send back to the server here. Okay, uh, and then they send the encrypted data over the unsecured network here. So then, like again, hacker Ame came here, right? Hacker Ame will not leave us here, right? So let's see how hacker Ame will attempt to hack our system here, and how it actually gets eliminated by the public key infrastructure here. Okay, so same thing in first scenario. In first example, we have seen that the server's public keys get catched by the hacker MA, and he replaces that public key with its own public key, right? Okay, and the same thing happens here. He will catch the original certificate of the server here, and he will modify that digital certificate and send back to the browser here. And we will see that the two scenarios, like in two scenarios, the digital certificates gets modified. And also remember that the browser has the CS public key, right? Because it actually present in a OS. So HackerMA also uses one OS, right? So the HackerMA also has the CS public key here. It available to HackerMA also. Okay. Now let's see the two scenarios here. In first scenario, the original digital certificate, which includes the server's public key here, and the signature value, which is a hash value encrypted with private key of the CA. Right now, now what hacker Amir does that he will just modify the public key of the server here, not the signature value here. Okay, just one thing, which is the attacker's public key. Like the it will replace the server's public key with its own public key here, and it will just a minute. We will wait for 1 minute. Actually, the Aditya gets disconnected.
Sorry, my Discord crashed. Please continue.
Yes, yes.
And
Yes.
time,
Now we
please look at the time as well. It's already
yes, yes.
half an hour past 10.
Yes. Okay. Now, what a hacker does or the AME does here, he replaces own public key with the server's public key, right? Now it will send that digital signature to the browser here. So now browser again same does the same thing here, that he will calculate the hash of the digital certificate and decrypt the signature value here, and again compare that hash value which is actually created by one created by the CA and the actual hash here. So what do you think? The hash will remain same or gets changed here? Quickly, quickly.
It will
What do you
change
think?
obviously.
Yes, obviously it will change because the server's public key gets changed with the Amaze public key here, right? So now browser will identify that the hash is not matching here. So the actual digital certificate gets tampered here. Okay. So in first scenario, this in this way the attacking attempt is avoided. Let's see the second scenario. In second scenario, attacker will modify the both of the values, like saying the it will replace the server's public key and also calculate the hash again with that modified public key. But there is a catch here, right? We have seen that the CA uses his own private key to encrypt that hash value here. But the hacker doesn't have the CS private key, right? The CS private key is actually kept with the CA itself. So he will not able to encrypt that hash value here. Okay. So hacker doesn't have that private key here. So he's not able to make the signature value here. Okay. That's how the second scenario, the hacking attempt is get avoided here. Okay. And this might be the reaction of the hacker MA here, that because of the public key infrastructure, I can't do anything here. Okay. So that's the end of the PK here, public key infrastructure. And let's continue with the next topic here, which is a secure socket layer. So everyone knows about that, right? Everyone heard about that SSL, right? Let's continue with that topic here. Before that, we will see the first, which is one as an HTTP protocol here. So just tell me why we are using HTTP, why there is a need of HTTP. Okay, transfer of the data. Yes, right. So when you are using a HTTP here, so the all the communication happens between the browser and server is not encrypted here. It sends in the form of plain text here. Okay, so if there is a one like hacker like Amya, then he can actually read that data, sensitive data, which is transmitted between the browser and server, which is unsecure, right? So that's why the HTTPS is introduced here. So what HTTPS does that it will encrypt that data which is being transmitted in between the browser and server, so that the hacker will not understand that one. Okay, so the HTTPS is actually the like popular application of the SSL here. So HTTPS actually uses a SSL protocol at the backend here. So now let's continue with the SSL here. So the SSL is actually a cryptographic protocol which encrypts the communication in between the client and the server here. So the our data gets protected here. Okay, and it also provides the features like encryption, authenticity, and the data integrity. You all know about these things, right? So that's about the SSL here. Okay, so how these securities actually actually like um, maintained by the SSL is like the main crux of the SSL is the SSL handshake protocol here. Okay, so we'll discuss that handshake protocol. The same thing, I will not discuss all the steps here. The same thing we have seen in public key infrastructure example, that how the digital certificate gets validated by the browser, and then the public key gets extracted, then the session key is encrypted with uh, the public key of the server here. So the same thing happens here, that the server sends his own SSL certificate here. So SSL certificate is nothing but just one type of digital certificate here, and the same thing happens, right? The first scenario and the second scenario here. So that's how the SSL protocol works here. Okay. Now let's move on to the SSL applications here. The first one is a HTTPS. Like we know that, right? What is a HTTPS here, right? It actually uses SSL protocol at the backend for the security. Okay. Then the secure mail. We know that the simple mail transfer protocol is used for sending the mail, right? So the next version is the secured one is a SMTPS here. Okay. So it actually same uses SSL protocol at the backend for securing the mails here. Then the VPN, right? The client connects a VPN server here. Okay, so connect that server. The SSL is used and transfer all the data in between the VPN server and the client. The actual SSL is responsible here. Okay. Then the file transfer protocol FTP, right? To transfer a file, the FTP protocol is used. So if you are using SSL at the backend of the FTP, then it becomes FTPS, which is a secure version here. Then the API connection. We all know that in web applications we use the web APIs, right? Which is the RESTful APIs for the communication purpose, right? So to secure that communication, the SSL can be used at the backend. Then the payment gateways here, like in payment gateways, the things gets a little complicated, right? Uh, we have the most sensitive data with us, right? The banking name, the banking account, the number, then the UPI ID, then the pins. To secure that whole data, the SSL is used at the backend here. So these are the most like you can say the famous examples or the applications of the SSL here. So that is the end of this episode 3 here. So thank you for the joining this episode. So I will revise the what I will revise what we have seen in this episode. The first one, we have seen the overview of the blockchain, so how the cryptographic functions or the concept are used in a blockchain. Then the PGP, which is the pretty good privacy, which is a hybrid cryptography. Then the GPG, which is the implementation of the same like a PGP, but in open source manner. Then we have seen the PKI, which is a public infrastructure. What is the need of the PKI? And then we have seen the most famous SSL here. Okay. So thank you for the joining for thank you for joining this episode 3 here. And that is end of the
Okay.
episode 3 here.
So, how was it? Was that too much information to take in for one episode? Nice. Okay. So, that covers like the things that we covered in these three episodes. 99% of cases where we use cryptography in modern world, we covered everything. So now that you go on the internet, you see any, a hash or a public private key pair or anything, you'll know exactly what is going on behind that. So as I said, it covers basically 99.9% of everything that is out there, mostly. Now, there are a few obscure topics that remain, as well as we have to discuss things like the future of cryptography and everything. So there are new threats. I think the quantum computer made by Google made news recently, right? Below. So that uh, somehow threatened the threatened blockchain and all this public infrastructure. So we hope to discuss all of those things in the next episode. And what are there are basically new algorithms being built. Now all of these algorithms, they are mostly 30 years old, 20, 30 years old. RSA, DSA, everything. Now there are new techniques like lattice-based cryptography and hash-based cryptography. as well as the we'll also look into the threats that the quantum computing poses, like Shor's algorithm and Grover's algorithm, everything. So uh, I hope you will tune into the next episode. We'll also discuss some other topics like steganography, like hiding of information in images, and a lot of other interesting, minute details about cryptography that we left behind. Okay, thank you, everyone. So, uh, that was it. Bye bye.